Sophie's favorite part of the morning was when her mom poured her a nice fresh frosty glass of milk before school. She would jump out of bed, run to the kitchen, and drink her milk. One morning, as she sat down, she noticed a strange smell coming from the glass.
Ew, she thought. She asked her mom if it was okay to drink. I'm not sure, replied her mom with a frown. I wouldn't risk it, but Sophie took a sip anyways.
Yuck! She spat it out. This tastes terrible. What happened? As soon as those words fell from her lips, she felt a small tap on her shoulder. She whipped around. A small fairy man was flying near. "Hi," he said. "I'm Rex N. Want me to tell you how the milk soured?" I guess.
Rex N then proceeded to start on a very long, very confusing lecture. Whoa, 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 slow down, exclaimed Sophie. I'm so sorry, let's start with something simpler. Have you ever seen rust? Yes. Well, what causes it? When you put metal outside? Exactly. What does that have to do with anything? Well, both situations are reactions.
Reactions make things go boom and bang and whoosh and change color and texture. They make things crinkle and hiss and rust and sour. Chemical reactions are the best. Whoa, said Sophie. Sorry, I got a bit carried away. It's quite all right. Back to rust.
The iron, which we chemists call Fe, and the oxygen gas in the air react to form rust. But what to call that rust? You might think that we would just call it FeO3 because that's what it forms, but that is not the case.
It's like they are on a teeter-totter, and there needs to be the same number of Fe's and O's on each side. What you do is add numbers called coefficients in front of the elements and compounds to balance it.
You also add abbreviations to show what state it's in. The abbreviations are L for liquid, S for solid, G for gas, and AQ for something dissolved in water. The final equation looks like this.
Alright, so the reaction that we just did, rust, is an example of a synthesis reaction. It's just like fruit salad. If the O2 is the bananas and the Fe is the oranges, you mix them all together and create the fruit salad, or 2F2O3. Okay, that makes sense. Are there other types of reactions?
The next type is called a decomposition reaction. Are you a picky eater? Of course not, but my friend June is. Well, if June had a plate of pasta with veggies, she would pick it out, right? Right. That's just like a decomposition reaction. They start all mixed together and end up picked apart. Like 2HGO yields 2HGl plus O2G. Alright, on to combustions. These are a bit more specific. Combustions happen when something reacts with oxygen to create heat and light. For example, if you were to react methane with oxygen gas, you would get carbon monoxide and water.
The next is called a single displacement reaction. If two kids are playing dress up and one has a crown and the other has a wig and a tutu, then the second kid gives the first the wig. That is single displacement. If we put in real elements, it looks like this: 2 HCl aqueous plus Mg magnesium solid yields H2 gas plus MgCl2 aqueous.
Finally, there's double displacement. It's exactly like two friends trading clothes. If one friend is named Effie and is wearing S, and her friend H is wearing Cl, it ends up looking like this: FeS solid plus 2HCl aqueous yields FeCl2 aqueous plus H2S gas. Do you want me to read that one?
The final thing that you need to know is called the activity series of the elements. It is just a list of which elements want to react with each other. You just look up an element on the list, and then the lower it is, the less reactive it is. Oh no, my dear, I'm needed in Sri Lanka. A little boy there does not understand electrons. But before I go, here is a list of the activity series of the elements that my grandfather gave me.
But Rexen, cried Sophie, what about the sour milk? Next time, my dear, next time. And he vanished with a pop. Sophie, called her mom, get in the car, we're going to get some new milk. Yay, Sophie cheered. The end.